more than 1,000 missiles. That's roughly how many stealth cruise missiles the United States has reportedly fired into Iran since this war began. A weapon designed from the ground up to fly low, fly quiet, and slip past radar systems that were never built to catch something shaped and coded the way this one is. Stick with me for the next few minutes, because we're going to walk through exactly what this missile is, how it's been reshaping this entire air campaign, and why, despite being one of the hardest things in the sky to detect, pieces of it keep turning up intact on the ground inside Iran, sparking a very different kind of alarm back among defense planners. The weapon is called the JASSM, officially the Joint Air-to-Surface Standoff Missile, and specifically its extended-range variant, the AGM-158B, known throughout the defense world simply as JASSM-ER. Until recently, according to analysis from Defense Security Asia, this missile had generally been used sparingly, fired in limited numbers against carefully selected targets. This war changed that completely. For the first time in the missile's history, JSSM transitioned into what analysts describe as a routinely expended operational munition, meaning it stopped being a rare, precious asset, saved for only the most critical strikes, and became something American commanders were willing to fire again and again, night after night, as a core part of a sustained air campaign. Let's talk about the missile's own development history for a moment, because it helps explain why this particular shift in usage patterns is such a genuinely significant milestone. The baseline AGM-158A JASSM entered service back in 2009, with the extended-range AGM-158B variant following roughly 5 years later in 2014. For over a decade after that, this remained a weapon reserved almost exclusively for the most sensitive, highest-value strike missions, the kind where a mission planner would rather spend $2 million on a single missile than risk a manned aircraft or accept the possibility of mission failure against a heavily defended target. In recent years, procurement had already been shifting away from the baseline JSSM toward the extended-range variant, specifically reflecting a growing recognition that standoff strike capability, hitting a target from far outside an enemy's engagement envelope, was going to matter more and more as adversary air defenses kept improving. This war is where that long strategic shift finally met a real, sustained shooting conflict, and the missile's entire operational profile changed almost overnight as a result. Let's talk about why this specific missile earns the description, "No radar could stop it," because the engineering behind it is genuinely built around defeating exactly that problem. JASSM-ER combines a reduced radar cross-section, shaped and coded specifically to scatter rather than reflect radar energy, with a terrain-following flight profile that keeps it hugging the ground at low altitude, well beneath the coverage envelope of most search radars. It navigates using a combination of GPS and inertial guidance for the mid-course flight, then switches to an autonomous imaging infrared seeker in the final seconds to lock onto its target with precision, all without needing a human operator guiding it in real time or a continuous signal that an adversary could jam or track back to its source. Stay with this one, because the range is what makes this weapon genuinely dangerous from a defender's perspective. According to figures reported by Defense Security Asia, JASSM-ER extends its strike reach to somewhere between roughly 925 and 980 kilometers, allowing the aircraft that launches it to attack heavily defended targets deep inside Iran, while staying completely outside the engagement range of Iran's surface-to-air missile systems. Think about what that actually means operationally. The bomber or fighter carrying this missile never has to enter the threat envelope at all. It releases the weapon from a position of near total safety, turns around, and heads home, while the missile itself does every bit of the dangerous work alone, flying hundreds of miles through contested airspace, completely unmanned. Now let's talk about which aircraft have actually been carrying this weapon into combat, because it's become something close to the connective tissue linking America's entire strategic bomber and fighter fleet together in this war. According to Army Recognition's reporting, JASSM variants are integrated across the B-52H Stratofortress, the B-1B Lancer, the B-2 Spirit, the F-15E Strike Eagle, the F-16 Fighting Falcon, the F-A-18E F Super Hornet, and the F-35A Lightning II. A single B-1B can reportedly carry 24 of these missiles at once, while a B-52H, equipped with the internal weapons bay upgrade, can carry 20, split between 8 housed inside the bomb bay on a rotary launcher, and 12 more mounted externally on wing pylons. Put 2 B-1B bombers together in a single formation, and you're looking at a potential wave of 48 precision-guided cruise missiles launched in one coordinated pass, a strike density that used to be associated almost exclusively with massive Tomahawk salvos fired from the sea. Let's linger on the B-52 specifically for a moment, because its role in this campaign is a genuinely interesting story about an old airframe finding new relevance. Army Recognition reported photographs of a B-52H Stratofortress taxiing for takeoff carrying AGM-158 JASSM missiles, mounted under its wings during the campaign's opening stretch. when the aircraft was used specifically to strike Iranian ballistic missile facilities and command and control nodes as part of a broader effort to degrade Iran's missile forces and coordination capabilities right from the earliest days of the war. Because JASSM strikes are launched from well outside Iranian airspace, rather than during direct overflights, the B-52's own aging airframe and comparatively modest radar signature barely matter. The missile itself does all the penetrating work once released, which is precisely why a bomber first designed decades ago can still play a genuinely central role in a war fought against a modern, layered air defense network. That operational logic extends across the entire mixed fleet carrying this weapon, and it's worth understanding why planners chose to spread JASSM integration this widely, rather than concentrating it on just one or two platforms. Every aircraft on that list, from the aging B-52 to the newer F-35A, brings a different combination of range, payload, basing flexibility, and radar signature to the fight. A B-1B flying from a forward base can deliver a massive single-pass salvo. An F-35A operating closer to the front line can slip into position using its own stealth characteristics before releasing a smaller number of missiles with even less warning. Spreading the weapon across that many platforms means mission planners always have an option suited to whatever specific target set and risk tolerance a given night's strike package requires, rather than being locked into a single delivery method that Iranian air defenses could eventually learn to anticipate and counter. Here's where the scale of this campaign becomes genuinely staggering. Reports cited by Defense Security Asia indicate more than 1,000 JASSM and JASSM-ER missiles have been expended during the opening phases of this campaign and the coordinated Israeli strike operations that ran alongside it. 1,000 missiles, each one individually engineered to slip past sophisticated air defense networks, fired in a matter of weeks, rather than being rationed out across years the way this weapon had historically been used. Separately, Bloomberg reported that the United States has been preparing to commit a large share of its remaining inventory of JASSM-ER missiles to this specific campaign, drawing down stockpiles that had previously been earmarked for entirely different regions of the world. Let's sit with that detail for a second, because it tells you something important about how seriously this fight has been treated. Every single JASSM-ER pulled from a stockpile allocated to another region is a missile that theater no longer has available if a separate crisis erupts somewhere else. According to reporting on that same Bloomberg story, U.S. and Israeli officials said a significant portion of Iran's air defense systems had already been destroyed by that point in the war, which they said was enabling the use of cheaper munitions in some operations. That's a genuinely important strategic signal, suggesting commanders felt confident enough in how degraded Iran's air defenses had become that they could start supplementing the expensive stealth missiles with less costly alternatives, even while continuing to draw down the JASSM-ER stockpile itself. Now here's the twist in this story that deserves the most attention, because it's the part that has genuinely surprised a lot of people watching this war closely. Despite everything this missile is engineered to do, fly low, fly quiet, and avoid detection entirely, pieces of it keep showing up completely intact on Iranian soil. According to Defense Security Asia, Iranian forces have recovered what appears to be at least the third documented case of an intact WDU-42B penetrator warhead from a JASSM missile. The most recent instance surfaced in Iran's Kurdistan province in the country's northwest. Photographs circulating across defense open-source networks showed Iranian military personnel handling a large cylindrical penetrator warhead suspended over cratered terrain, showing visible impact damage but remaining structurally intact despite what would have been an extremely violent high-energy ground impact. Now let's talk about why that specific warhead surviving intact isn't actually as contradictory as it sounds, because the engineering explanation is genuinely fascinating. The WDU-42B penetrator, sometimes referred to in defense documentation as the J-1000, carries roughly 1,000 pounds, or about 450 kilograms, of penetrator mass, and it was specifically engineered to survive violent impact sequences before triggering a deliberately delayed detonation, timed to go off only after burrowing through rock, soil, or reinforced concrete to reach buried command centers, hardened shelters, and underground military infrastructure. In other words, that warhead surviving the initial impact isn't necessarily proof of a failure at all. It's arguably the warhead doing exactly the first half of its job as designed, engineered specifically to punch through layers of hardened material before the explosive charge goes off deep inside a target. What's actually notable here isn't that the warhead survived impact. It's that in these specific instances, it apparently survived without completing the second half of its job. There's a second piece of this warhead's engineering worth understanding, because it explains why Iranian access to it carries genuine intelligence value beyond just the metal casing itself. According to Defense Security Asia, the warhead reportedly contains a material called AFX-757, an insensitive explosive specifically engineered to reduce the risk of accidental detonation during storage, transport, and combat handling, while still delivering sufficient destructive force against hardened targets once it does go off. Insensitive munitions technology like this represents a genuinely significant area of investment across the American defense industrial base, precisely because it lets forces store and move powerful explosives with dramatically reduced risk of an accidental detonation caused by rough handling, a stray spark, or even a direct hit from an enemy strike on a storage depot. If Iranian chemists and materials scientists can study a recovered sample of that specific formulation, they gain insight into an area of explosives engineering that's been a genuine competitive advantage for Western militaries for years. Here's why that detail matters so much more than it might first appear, and it's the reason this story genuinely deserves the word alarm attached to it. Repeated access to intact components like this could potentially allow Iranian defense laboratories to study the missile's insensitive explosive formulation, its fuse sequencing architecture, and the metallurgy and structural characteristics behind American stealth cruise missile design. The warhead's FMU 156 smart fuse is particularly sensitive from an intelligence standpoint, because according to Defense Security Asia's reporting, that fuse system reportedly differentiates between rock, soil, concrete, and layered structures in real time, calculating the optimal delayed detonation timing needed to maximize penetration effectiveness against deeply buried targets. If Iranian engineers can reverse engineer that specific logic, they gain genuine insight into how American precision strike doctrine actually calculates and executes attacks against hardened underground infrastructure, exactly the kind of targets both Iran and its allies have invested heavily in building. It's worth pausing on why the fuse technology specifically represents such a uniquely valuable intelligence target compared to almost any other component on the missile. Reverse engineering a missile's aerodynamic shape or its basic guidance electronics tells an adversary something about how the weapon flies and navigates, information that's genuinely useful but also to some extent inferable just from watching enough missiles in flight or studying publicly available specifications. The fuse's target discrimination logic is different because it represents the accumulated result of extensive American testing against real hardened structures, encoding assumptions about exactly how deep a warhead needs to travel through specific material types before detonating for maximum effect. That's the kind of institutional knowledge that takes years, and often live-fire testing against representative structures, to develop properly. And it's precisely the kind of knowledge that's most valuable and most dangerous to lose to a determined adversary studying recovered hardware. The strategic concern here also extends well beyond Iran's own borders, and that's worth understanding clearly. Iran has historically maintained close intelligence and technology-sharing relationships with both Russia and China, two countries that have invested enormously in their own efforts to defeat exactly the kind of low observable precision-guided weapons JASSM-ER represents. Any technical insights Iranian engineers manage to extract from these recovered warheads don't necessarily stay contained within Iran's own defense establishment. They can plausibly circulate through that broader network of aligned states, each one working on their own version of the exact same problem: how to detect, track, and ultimately defeat American stealth cruise missiles before they reach their targets. That's the genuinely uncomfortable strategic reality sitting underneath what might otherwise look like a purely regional battlefield curiosity. Now, some honesty about what these recoveries actually prove, because Western analysts have consistently urged caution here. Independent verification of these Iranian recovery claims remains limited, because publicly available imagery doesn't conclusively establish whether these specific missiles were intercepted by Iranian air defenses, experienced a mechanical malfunction, suffered a navigation failure, or simply failed to detonate correctly after reaching their target. Iranian state-linked media has understandably framed these recoveries as proof that America's most advanced stealth weapons can be intercepted and neutralized, a narrative with obvious propaganda value regardless of the actual underlying cause. The honest, responsible read here is that we genuinely don't know which explanation is correct in any individual case, and it's entirely possible different recoveries have different causes behind them. What we can say with more confidence is the raw math behind why recoveries like this become statistically inevitable at this kind of scale. When you fire more than 1,000 missiles into contested airspace over the course of a few weeks, even a very low individual failure rate, whether from interception, malfunction, or non-detonation, produces a meaningful number of intact or partially intact components scattered across the battlefield. That's simply what happens when you deploy a weapon this complex at genuinely industrial volume, rather than in the rare, carefully selected strikes it was historically used for. The scale of this campaign didn't just stress America's missile inventory, it also mathematically guaranteed more opportunities than usual for exactly this kind of battlefield exploitation to occur. Let's talk about the cost side of this equation, because it connects directly to why the scale of this campaign matters so much strategically. According to figures reported by Defense Security Asia, each JASSM missile runs at approximately $2 million. Multiply that by the more than 1,000 missiles reportedly expended in this campaign's opening phases, and you're looking at a munitions expenditure that runs well past $2 billion on a single class of weapon in a matter of weeks. That's the kind of number that forces defense planners to start asking uncomfortable questions about production timelines, replenishment capacity, and whether peacetime assumptions baked into America's stockpile planning ever actually accounted for a conflict consuming missiles at this pace. It's worth understanding what actually goes into replacing a missile like this once it's fired, because the price tag reflects a genuinely complex manufacturing process rather than an arbitrary number. JASSM-ER production involves specialized composite airframe manufacturing to achieve its reduced radar cross-section, precision machined guidance components, the imaging infrared seeker assembly, and the warhead and fuse systems already covered here, each built to exacting tolerances by a supply chain that can't simply scale up production overnight in response to a sudden spike in wartime demand. Lockheed Martin, the missile's primary manufacturer, operates on production schedules planned years in advance based on peacetime procurement contracts, meaning a war that burns through 1,000-plus missiles in a matter of weeks creates a replenishment gap that could take years of accelerated production to fully close, even with emergency funding and expanded manufacturing capacity. Here's the strategic tension sitting underneath all of this, and it's one that keeps showing up throughout this entire war, regardless of which specific weapon system we're talking about. JASSM wasn't originally built or stockpiled with a regional conflict against Iran as its primary justification. It was funded and produced with an eye toward exactly the kind of sophisticated, heavily defended targets a future confrontation with a near-peer power might present. Every missile drawn down against Iranian targets, including the ones that ultimately failed to detonate and ended up as recovered battlefield debris, is a missile that theater no longer has available for whatever comes next elsewhere. That's the same underlying math that has shaped concerns about other scarce American weapons programs throughout this war, a strategically vital capability being consumed against a regional adversary, while the broader deterrent value that capability was originally built for sits somewhere in the back of every defense planner's mind. That tension isn't just an abstract concern being raised by outside commentators either. It's reflected directly in how officials have talked about this campaign's own trajectory. Recall that officials specifically framed the shift toward cheaper munitions in some operations as something enabled by Iran's degraded air defenses, a detail that only makes sense as a genuine strategic consideration if the alternative, continuing to rely primarily on expensive JASSM-ER missiles, was becoming a real constraint on how the campaign could be sustained going forward. That's military planners essentially telling you through their own operational choices that the stealth cruise missile stockpile wasn't infinite, and that finding ways to substitute cheaper weapons wherever Iranian defenses had been degraded enough to allow it wasn't just a cost-saving measure, it was a genuine effort to preserve JASSM's dwindling inventory for the specific targets that still required its unique combination of stealth and precision. Let's talk about the geography of where these recoveries have been happening, because it tells you something about how this missile campaign has actually been flown. Kurdistan province sits in Iran's northwest, occupying a strategically sensitive position near the borders of Iraq and Turkey, close to a web of regional surveillance corridors and overlapping military activity. The mountainous terrain in that specific region complicates both offensive and defensive aerospace operations, influencing radar horizon limitations, electronic warfare effectiveness, and the navigation profiles cruise missiles rely on to avoid detection. It's plausible that missile trajectories running through that specific corner of Iran were deliberately chosen to exploit terrain masking or gaps in radar coverage, reducing exposure to the more heavily fortified air defense clusters protecting Iran's central and southern regions, including the dense coastal defenses built up around cities like Bandar Abbas. That contrast is worth sitting with for a moment, because it highlights just how uneven Iran's actual air defense coverage has been throughout this war. Bandar Abbas and the surrounding coastline sit at the absolute center of Iran's most heavily defended military infrastructure. The naval bases, the coastal missile batteries, the radar network specifically built to protect the Strait of Hormuz's choke point. A missile campaign routing itself through the mountainous terrain near Kurdistan province, hundreds of miles away from that dense coastal defense cluster around Bandar Abbas, tells you mission planners were actively seeking out exactly the kind of radar gaps and terrain masking that let a low observable weapon like JASSM-ER do what it's designed to do, rather than testing its stealth characteristics against Iran's most concentrated and sophisticated defenses head-on. Let's zoom out and think about what this specific weapon story tells us about modern precision warfare more broadly, because this is probably the most important takeaway from everything covered here. Every failed missile, every crashed drone, every partially intact munition recovered from a battlefield becomes, whether either side intends it to or not, a genuine intelligence asset with consequences that outlast the war itself. Iran's recovery of these warheads doesn't just generate a propaganda moment for state media. It creates a real, lasting technical record that Iranian engineers, and potentially their intelligence partners in Russia and China, can study for years after this specific conflict ends. That's the uncomfortable trade-off built into deploying advanced stealth weapons at the kind of scale this war has required. The more of them you fire, the more valuable technical data you inevitably hand to the exact adversary you're trying to defeat. It's worth being transparent about where every piece of this comes from, because a story built around classified adjacent weapons technology only holds up if the sourcing is solid. The missile's technical specifications, its range, guidance system, and warhead design come from a combination of Defense Security Asia's reporting and Army Recognition's coverage of the B-52H's integration with the JASSM family. The scale of the campaign, the 1,000-plus missiles expended, and the near total inventory commitment comes from Bloomberg's original reporting as carried forward by other outlets, alongside Defense Security Asia's independent figures on munitions expenditure. And the recovery of the intact warhead in Kurdistan province comes from open-source imagery analysis reported by Defense Security Asia, which was consistently careful throughout its own reporting to flag exactly what remains unverified about the incident's underlying cause. It's also worth flagging that this recovery wasn't presented as an isolated event, even in the original reporting. That context matters for how seriously to weigh it. Defense Security Asia specifically described this recovery as at least the third documented case of an intact WDU-42B warhead, surfacing since the war began, meaning this wasn't a single anomalous incident, but part of an established recurring pattern. 3 separate recoveries across 3 separate incidents is a meaningfully different story than a single isolated piece of battlefield debris. It suggests either a consistent, repeatable failure mode affecting some percentage of missiles fired, a genuine and repeatable Iranian interception capability against at least some JASSM strikes, or, most likely given the honest uncertainty here, some combination of both happening in parallel across different individual engagements. That caution is worth repeating one more time before wrapping up, because it's the single most important caveat in this entire story. There is no real confidence from outside sources about whether these recovered warheads represent successful Iranian interceptions, mechanical failures, or simple non-detonation events. Iranian state media has an obvious incentive to frame every recovery as proof of a successful shootdown. American and allied defense analysts have an equally obvious incentive to attribute the same recoveries to mechanical failure rather than admit any gap in stealth performance. The honest answer sits somewhere in that gap, unresolved, and it will probably stay that way until independent forensic analysis becomes available long after this war has ended. So where does this actually leave things right now? The United States has fired more stealth cruise missiles into Iran over the recent stretch of this war than the specific weapon had likely been used in its entire prior operational history combined, engineering a genuinely unprecedented demonstration of standoff precision strike capability that Iran's air defense network was never built to fully counter. And yet, scattered across the mountains of Kurdistan province and elsewhere, intact pieces of that same supposedly undetectable weapon keep turning up in Iranian hands, feeding a slower, quieter intelligence war that will likely outlast the shooting war itself by years. Both of those things are true at the same time. A weapon that's fundamentally reshaped how this air campaign has been fought, and a weapon that's simultaneously handing its adversary a genuine technical education in exactly how it works, one recovered warhead at a time. That dual reality is probably the single most useful way to think about advanced precision weaponry in general, not just this specific missile in this specific war. Every major military power investing in low observable precision-guided strike systems is making an implicit bet that the operational advantage gained from using the weapon outweighs the intelligence risk created every time one fails, misses, or gets recovered by the side it was aimed at. That bet generally pays off when a weapon is used sparingly, in small numbers, against carefully chosen targets, exactly how JASSM operated for most of the decade before this war began. It becomes a genuinely different calculation once a weapon shifts into the kind of high-volume, routinely expended use this campaign has demonstrated, because volume itself changes the math. More launches simply means more chances for something to go wrong, in a way that hands real technical value to the people standing underneath it. Whether this trade ultimately proves worth it likely depends on questions this war alone can't fully answer. How much genuine operational advantage the JASSM-ER campaign actually delivered against Iran's air defense and command infrastructure, weighed against how much of a head start these repeated recoveries hand Iranian, Russian, and Chinese engineers working to defeat the exact same missile technology in some future conflict. That's not a question with a clean, satisfying resolution available right now, and it's exactly the kind of open, strategic question that tends to only get answered years later, once the next generation of countermeasures either does or doesn't show up on a modern battlefield somewhere else in the world, What's genuinely worth sitting with here, right now, is the size of the bet being placed. A stockpile built for a future confrontation with a much larger power is being drawn down, missile by missile, against a regional adversary that, despite months of sustained pressure, has still managed to hand back a slow trickle of intact hardware every few weeks. That's not a story about a weapon failing. It's a story about what it actually costs, in the long run, to use the most advanced tool in the box at industrial scale, rather than in the rare, careful doses it was originally designed for. And that's a cost that won't fully show up on any balance sheet until long after the current headlines have faded, when the next set of engineers, wherever they happen to be working, sit down with everything they have learned from a handful of recovered warheads and start designing the system meant to catch the next one. That's the fuller picture behind a weapon that was never supposed to be seen, let alone recovered intact, and why what's happening quietly in the mountains of Iran's northwest right now might end up mattering more, over the long run, than any single night of headline-grabbing strikes. Let's take a moment to think through what the alternative to this approach would have actually looked like, because it puts the scale of this decision into sharper focus. Without a weapon like JASSM-ER available in this kind of volume, striking heavily defended targets deep inside Iran would have required either accepting far greater risk to manned aircraft flying directly into contested airspace, or relying more heavily on shorter-range munitions that would have forced pilots to fly closer to the exact air defense systems this campaign has spent months degrading in the first place. Every single stealth cruise missile fired from outside Iran's engagement envelope is, in a very direct sense, a pilot who didn't have to fly into a heavily defended zone that night. That's the trade being made every time a B-1B or an F-35A releases one of these missiles from a position of relative safety. The intelligence risk created by a recovered warhead is real, but it exists specifically because the alternative, sending crewed aircraft deeper into contested airspace, carries a different and, in many ways, more immediate risk, the kind involving actual human lives rather than future battlefield forensics. Understanding that trade-off is essential to understanding why commanders have been willing to accept the recovery risk at all. It isn't that anyone views handing Iran, Russia, and China a trickle of recovered hardware as a good outcome. It's that the alternative, in a campaign requiring this many strikes against this many hardened targets, was judged to carry a worse one. There's also a broader industrial story sitting underneath all of this that's worth pulling out on its own, because it connects directly to a debate that's been running through American defense policy circles for years now, long before this specific war began. Analysts have repeatedly warned that the American defense industrial base, built around slow, predictable, peacetime production schedules, was never designed to absorb the kind of consumption rate a sustained, high-intensity conflict against a capable adversary would actually require. This campaign against Iran, a regional power rather than a peer competitor, has already burned through enough JASSM-ER inventory to force emergency conversations about replenishment timelines and production capacity. Extend that same consumption logic to a hypothetical future conflict against a country with a far larger and more sophisticated air defense network, and the math becomes considerably more alarming. If a regional campaign against Iran required drawing down a meaningful share of the total JASSM-ER inventory in a matter of weeks, a conflict against a near-peer power, one that would likely require sustained strikes against a vastly larger number of hardened, heavily defended targets over a much longer timeline, could plausibly exhaust the entire stockpile in a fraction of the time anyone in prior planning had originally assumed. That's precisely the kind of uncomfortable arithmetic that tends to drive urgent, if quiet, conversations about expanding production lines, diversifying suppliers, and investing in cheaper standoff alternatives that could shoulder more of the burden in future conflicts, freeing up the most expensive and most strategically sensitive munitions for only the targets that genuinely require them. It's also worth pausing on how this specific war has effectively functioned as an unplanned real-world stress test of assumptions that had, until now, mostly existed inside simulations, tabletop exercises, and classified planning documents. Peacetime procurement planning tends to rely heavily on modeled consumption rates, estimates built from historical usage patterns, previous limited conflicts, and analytical projections about how a future war might unfold. Those models are useful, but they're still models, built on assumptions that can only be fully tested once a real, sustained conflict actually happens, and forces planners to confront how those assumptions hold up against the messy, unpredictable reality of an actual extended air campaign. This war has effectively provided exactly the test, not against the kind of adversary the weapon was originally built to counter, but against a regional power whose air defenses, while real and at times effective, don't remotely approach the scale or sophistication of what a near-peer conflict would require. If the assumptions embedded in prior planning models are already straining against a regional test case like this one, that's a genuinely important signal worth taking seriously, regardless of how this specific war in Iran ultimately concludes. There's one more angle worth exploring before wrapping this up, because it speaks directly to how militaries actually learn from moments like this one over time. Every recovered warhead, every documented failure mode, every piece of battlefield debris that ends up photographed and analyzed by open source intelligence communities becomes part of a much longer feedback loop that shapes how the next generation of these weapons gets designed. It's reasonable to expect that engineers working on the next iteration of America's standoff strike arsenal are already studying exactly the kind of recovery incidents documented here. Not because of any single leak or breach, but because publicly available reporting on recovered hardware is itself a valuable diagnostic tool for identifying whatever specific failure modes, whether mechanical, electronic, or related to fuse timing, might be producing these non-detonation events in the first place. In that sense, even the uncomfortable parts of this story, the intact warheads, the propaganda value handed to Iranian state media, the intelligence risk to Allied technology, are simultaneously feeding directly back into how the weapon itself will eventually be refined and improved. War, in that sense, has always functioned as an unusually blunt but effective feedback mechanism for military technology, and this specific missile campaign is simply the latest, highly visible example of that much older pattern playing out in real time. Put all of that together, the scale of the campaign, the cost per missile, the industrial strain on replenishment timelines, the intelligence risk from recovered hardware, and the broader lessons this war is quietly teaching about the limits of peacetime stockpile planning. And what emerges is a story considerably bigger than any single strike or any single recovered piece of debris. It's a story about how a weapon originally built and stockpiled with an entirely different kind of conflict in mind ended up becoming the backbone of a real, sustained regional air campaign. What that transition actually cost in dollars, inventory, and quiet intelligence exposure, and what it might mean for how the next war, wherever and whenever it happens, gets planned, resourced, and fought. That's the fuller picture behind a weapon that was never supposed to be seen, let alone recovered intact, and why what's happening quietly in the mountains of Iran's northwest right now might end up mattering more, over the long run, than any single night of headline-grabbing strikes